Algebra 2, here we are with standard 6A summative review. We're working on the right-hand side. Okay, we're breaking down a cube root. So if you forgot your cubes to test, okay, it's not too tough. 2 to the third, 3 to the third, 4 to the third. You can figure those out with your calculator. So we'd have 8, 27, 64. You can keep going down the line. Alright, we're going to have 8 going into 56. Cube root of 8 times 7. We can do the cube root of 8. It's going to be 2, and then we'll have the 7 left over. Now powers, we divide by the root number. Okay, so does 8 divide by 3 nicely? No, it does not. So we're going to break that 8 up into one that does divide nicely and then a small leftover. And the leftover should be smaller than the root number. Otherwise, you could do it differently. So we're going to go c to the 6th and c squared. Okay, 10 does not divide nicely by 3, but we can go 9 and 1, and e to the 12th does divide nicely by 3, so we can leave it alone. Now, we've talked about this before, that some people like to go through and underline the ones they are going to do, or underline the ones they are not going to do. That's a strategy you can use. You don't have to. Okay, I am going to do the 8, c to the 6th, the d to the 9, and e to the 12. So the cube root of 8 is 2 on the outside. 6 divided by 3 will have c squared on the outside. 9 divided by 3 will have d to the 3rd on the outside. And e to the 4th. Leftovers on the inside will be the 7. C squared, d to the 1st. And you don't have to put the 1 up there. Alright, there we go. Number 4, parentheses to a power. Now this one's got a fraction in the power, so this is going to be a little bit more fun. I think your quiz and your test might be a little bit more along the lines of number 3, but we can do this number 4. This will really show if you know what's going on. Now when we have power, parentheses power, we're going to multiply the powers. Multiply the powers. So it's important here that we put a little 1 up top for the first power, so we don't make a silly mistake and end up doing 3 halves times 4. We're doing 3 halves times 1. So this is 4 to the 3 halves power. Okay, and then we'll have x. Okay, we multiply. I'm going to write them both here, just so you could see it playing out. X to the 2/3 times 3 halves power. Okay, what's 2 times 3 on the top? 6. What's 3 times 2 on the bottom? 6. And 6 divided by 6 is going to be x to the 1st power, or just x. Okay, 4 to the 3 halves. Now we're going to do this. This is going to be a little bit tricky. Okay, remember we talked about our fraction exponents. The top number is the power, the bottom number is the root. So really what we have is the square root of 4 cubed. That's another way to think of it. Or if you want to be lazy, no brain power, you could just type that into your calculator. Okay, 4, the square root of 4 is 2, and then 2 cubed is 8. 8x. Okay, now like I said, I believe your test and quiz are more like this one. Okay, but if you can do this one, that's even better. Sliding on down. Fixing the denominator. We got 5 plus radical 7. We're going to go 5 minus radical 7, top and bottom. So we picked the same two numbers with the opposite sign. Okay, the top's going to happen to be whatever it is. The bottom should be a nice number at the end. That's why we pick it. If you rewind your brain a little bit, this should go all the way back to difference of squares. Okay? Remember your difference of squares factoring? If it was like x squared minus 9, you do x plus 9, x minus 9. Okay, so that's kind of what we have going on here. 5 plus radical 7, 5 minus radical 7. That's why this works out. Okay, so everything times everything. So 3 goes to both of those. We'll have 3 times 5 for 15, minus 3 radical 7, minus 5 radical 7. Make sure that minus sign stays with it. Minus 5 radical 7. Negative times a negative is a positive. Radical times a radical is a regular 7. Bottom row, 5 times 5, we got 25. 5 times negative radical 7, we got minus 5 radical 7. And we got plus 5 radical 7. Okay, positive times a negative is going to be a negative. Radical times radical 7 is going to be a regular 7. And look at the bottom. This is how it's going to be a nice one. Minus 5 radical 7 plus 5 radical 7. Gone. On the top, we got 15 plus 7 for 22. Minus 3 minus 5, we got minus 8 radical 7. On the bottom, 25 minus 7. 25 minus 7, we have 18. Okay. Now take a look. 22, 8, and 18. They're all even, which means I should at least be able to reduce them all by a 2. So if I reduce them all by a 2, we got 11 minus 4 radical 7 over 9. All right. Backside. Cube root of a big fraction. Cube root of a big fraction. Okay? So step 1 is reduce the inside. What do we got? Okay, 3 over 48. Think of it as 48 over 3. 48 divided by 3 is 16 on the bottom. Okay, then we have x to the 4th, 4 minus 2 is going to be x squared on the bottom, and y to the 1st on the bottom. We got another tricky number. Usually the test isn't going to have a tricky number like 16 or 4, and those are tricky, or 16 or 8 or 4, because those can appear to be multiple things. Like 16, we could call that 16 to the 1st. We could call that 4 to the 2nd. We could call that 2 to the 4th. Okay, so that's going to be a weird one. I'm going to go with 4 squared. I'm going to go with 4 squared and see what happens. We'll scratch it off and call it 4 squared, because we're trying to do a cube root. Okay, so we need one more 4, top and bottom. We need one more x, top and bottom. And we need 2 more y's. So now we have cube root of 4xy squared. And now we'll have 4 to the 3rd power. If you want to write 4 to the 3rd power, you can. We'll have x to the 3rd power, and we'll have y to the 3rd power. So we fixed it so the whole bottom would be all cubes, because we're trying to do a cube root. So we got all cubes of this cube root. So now we have a nice one on the bottom. 4xy. Boom, boom, boom. And then across the top we got leftovers. Okay? I cannot do the cube root of 4. Even if you change it to a 2 squared, you still can't do the cube root of it. So we're going to leave it. We're going to leave the x, and we're going to leave the y squared. So changing it to a 4 squared was a good choice. There it is. Last one, number 10. Reducing radicals and combining. Okay, so we got to think about which ones we can break down into what. So 75 is hopefully a good one to start with. We'll have 4 times the square root of 25 times 3. So now we kind of have a hint as to what we're kind of shooting for here. One of these pairs is probably going to end in a radical 3. 27, pretty small. We can go 9 and 3. 99, how about 9 times 11? So we're probably thinking 11 for the other one too. plus square root of 4 square root 11. Now we're going to go back and do all the square roots that we can. Minus 2 times 3, radical 3. And again, some of you guys might be able to do this part in your head. Maybe skip this step. I would write it down just to be safe. Now I'm going to do the multiplication parts. We got 20 radical 3s, minus 6 radical 3s, minus 9 radical 11, plus 2 radical 11. Okay, we can put these two together. 20 minus 6, we got 14 radical 3. Put those two together, we got minus 7 radical 11. Okay, it's not always going to work out where those are going to be next to each other. You might have to look around a little bit, but there's only 4 things, so you shouldn't have to look too hard. Alright, so there's the right-hand side. You guys got the left-hand side on your own. Be checking Schoology and your email for that answer key, and the test should be very similar tomorrow. Good luck!